Okay, so what we're going to do today is chapter 8, and we're going to look at hypothesis testing. And as far as the book is laid out, there's 3 types of hypothesis testing that can be done. There's hypothesis testing for a population proportion, right, which is P as a mathematical symbol. There's also hypothesis testing for the mean, which is mu. And there's also hypothesis testing for the standard deviation, which is chi-square. And we'll talk a little more about that as time goes. I'm going to go to our shared screen, and I'm going to pull up PowerPoints. And so in this section, we're going to take a look at hypothesis testing. So in hypothesis test, first off, a hypothesis is basically an educated guess. In statistics, a hypothesis is a claim or a statement about a property of a population. A hypothesis test, or sometimes called a test of significance, is a procedure for testing a claim about a population. And so a hypothesis is made, or an educated guess, and then a test is performed about that hypothesis to see if it's true or not. When testing for a hypothesis, there's something called the null hypothesis. And the null hypothesis is denoted by this H sub 0 or H sub naught. And it's a statement that the value of the population parameter is equal to some claim value. So whenever you're writing out your null hypothesis, you must write it out as equal to some value. Okay, so with that being said, I'm going to open up our homework, and we'll take a look at a couple of examples. So the very first one, I'm just sort of fill in a blank, and this statement reads, the blank hypothesis is a statement that the value of a population parameter is equal to some claim value. All right, so from the definition we're given, that would be the null hypothesis. All right, so keep in mind that the null hypothesis is always equal to some claim value. I next want to look at problem number 9. Okay, so in problem number 9, we're asked to set up the null hypothesis. So this question reads, a formal hypothesis test is to be conducted using the claim that the mean body temperature is equal to 98.6 degrees Fahrenheit. What is the null hypothesis and how is it determined? So first, in setting up our hypothesis, our null hypothesis, since we're talking about the mean, we're going to use mu. So notice that in these notations, here I have the null hypothesis is that the mean, or mu, is 98.6. If I look at choice D, it also denotes the mean. However, but in choices B or C, notice that they're denoting the population proportion. So I'm going to choose answer choice A. The null hypothesis is that the mean is equal to 98.6 degrees Fahrenheit, because in our problem, we're making a claim about the mean, and that null hypothesis must be equal to some claim value. And I also want to take a look at problem number 12. Okay, I thought it would give me something different. Here again, we're setting up another hypothesis test. So this reads: a formal hypothesis test is being conducted using the claim that the mean AC thermostat setting in restaurants is equal to 74 degrees Fahrenheit. What is a null hypothesis and how is it denoted? So here again, in this example, the mean is denoted. So I'm going to search for the null hypothesis that shows the mean. The null hypothesis must also be equal, so I'm going to choose answer choice A. All right, I'm going to go back to our PowerPoints. So now we'll talk about the alternative hypothesis. The alternative hypothesis can be denoted a couple of ways. It can be denoted as H sub 1, H sub A, lowercase a, or H sub capital A. Okay, but in either case, we're making a reference to the alternative hypothesis. And the alternative hypothesis is a statement that the parameter has a value that somehow differs from the null hypothesis. The symbols that we're going to use are going to be less than, greater than, and not equal to. So just taking a look at a couple of examples, I now want to take a look at problem number 7. Okay, so in problem number 7, we're asked to set up both the null and the alternative hypothesis. So this question reads: a psychologist claims that more than 5.8% of the population suffers from professional problems due to extreme shyness. Use P, the true percentage of the population that suffers from extreme shyness. So in this example, we're using P. Anytime you're given a percentage value, you want to use P as a population proportion. So as we set up, and if we notice all of our answer choices contain P. When setting up your null hypothesis, notice that you must always be equal to some claimed value. So if I take a look at each one of these, they have the correct null hypothesis. They're all equal. How do I determine my alternative hypothesis? Well, here's the claim. It says that a psychologist claims that more than 5.8%. So if I think about more than 5.8%, I'm thinking about something that is greater than 5.8%. So I believe my correct answer choice here would be answer choice A. So remember that the null hypothesis is always equal. In this case, our alternative hypotheses, we're going to choose more than, which is the greater to inequality. I'm also going to take a look at number 11. Okay, so in problem number 11 here, again, we're setting up both the null and alternative hypotheses. This question reads that the manufacturer of a refrigerator system for beer kegs produces refrigerators that are supposed to maintain a true mean temperature. So we're talking about the mean mu of 48 degrees Fahrenheit. Ideal for certain type of German Pilsner. The owner of the brewery does not agree with the refrigerator manufacturer and claims that he can prove that the true mean proportion is incorrect. So first we're going to set up our null hypothesis. So here we're referencing the mean, so we're going to use mu. Also notice that the null hypothesis must be equal, and the claimed value is 48 degrees Fahrenheit. So as I look at my answer choices, answer choice A has the correct null hypothesis, and it's the only one that has the correct null hypothesis. Now, how do I set up my alternative hypothesis? Now, well, by choice of elimination, since the null hypothesis is correct for A would be my correct answer choice. But how do I determine my alternative hypothesis? Well, if I take a look at the very last sentence, it says that the owner of the brewery does not agree with the refrigerator manufacturer and claims that he can prove that the mean temperature is incorrect. So incorrect doesn't necessarily mean less than, doesn't necessarily mean more than. It means that it's incorrect or not equal to. So here, answer choice A would be the correct choice. Now, as far as your tests are concerned, you have a two-tailed test. You can have a left-tailed test or a right-tailed test. For a two-tailed test, the critical region is in the two extreme regions under the curve. So if I'm using a two-tailed test, right, my critical regions would be the gray area. For a left-tailed test, the critical region is in the extreme left of my curve. So for a less than, I have a tail test. If I have an equal to in my alternative hypothesis, I have a two-tail test. And then lastly, for a right tail test, the critical region is in the extreme right of the curve. So when I'm setting up my alternative hypothesis, if my inequality is greater than, I know I have a right tail test. So now I'm going to bring up problem number 10. Okay, and problem number 10, we're asked to determine the test. If it's a left tail, the right tail, or a two-tail. So this question reads, suppose we want to test the claim that the majority of adults are in favor of raising the voting age to 21. Is this a left tail, right tail, or a two-tail test? Well, if I look at my setting up my null and alternative hypothesis, my null hypothesis would be equal to that the voting age is equal to 21. My null hypothesis, it says that we want to test the claim that the majority of adults. So if we're talking about majority of adults, we're talking about the larger part of adults, or we're talking about a right tail test. Okay, so for problem number 10, as we set up that test, the majority of results would fall in the right-hand region, so we're looking at a right tail test. Okay, now we'll look at the next couple of slides, and we'll use these to actually test a claim. Okay, so the first thing we'll do is talk about a test statistic. And the test statistic is the value used in making a decision about the null hypothesis. Whether you're using a hypothesis claim about a proportion, a mean, or a standard deviation. As far as the calculations are concerned, we're only going to calculate test statistics about a population proportion. And here's the formula for the test statistic. So we're dealing with a z-test statistic, and that's equal to p hat minus p divided by the square root of p times q divided by n. Now, as far as these calculations, our calculator will actually calculate the z-test statistic. It'll calculate the p-value, and based on the p-value, we'll be able to either reject or fail to reject the null hypothesis. So how do we know when we reject or fail to reject the null hypothesis? Well, we use something called the significance level to make that determination. The significance level, which is alpha, and alpha will be given our problems. It's simply used to determine a cutoff value for our test statistic. So here again, the alpha value will be given. In order to determine if we will reject or fail to reject the null hypothesis, we'll use something called the p-value method. So once again, this p-value will be calculated using our calculator. So the p-value says that in a hypothesis test, the p-value is a probability of getting a value of the test statistic that is at least as extreme as the test statistic obtained from the sample data. What that means is if our p-value is less than or equal to alpha, which is our significance level, we're going to reject the null hypothesis. If the p-value is greater than our level of significance or alpha, we will fail to reject the null hypothesis. So now we'll take a look at two examples. We'll take a look at one example where the statistics are given. We're given the z-score, we're given the p-value, and we'll make a determination about our null hypothesis. And then in the second example, we'll use the calculator to calculate the statistics and make our determination. All right, so we're going to take a look at problem number 3. All right, so here's problem number 3. So notice that we're given a problem and we're also given some statistics. All right, so first off, before we actually read through the problem, let's look at the given statistics. It's a 1 proportion z-test. Our null hypothesis is that, our alternative hypothesis is that the proportion is less than 0.09. So as I read through the data, notice that if the alternative hypothesis is less than, then we would have a left tail test. If the null hypothesis was equal to, if the null hypothesis is not equal to, because remember the null hypothesis is always equal to, but if the alternative hypothesis is not equal to, I would have a two-tail test. And if the alternative hypothesis was greater than, I would have a right tail test. I'm given a z-test statistic, which is equal to negative 1.87. And if I go back to our slides, right, this is how you would physically or manually calculate the z-test statistic. But notice that statistic has already been calculated as negative 1.87. We're given a p-value. P is equal to 0.03. So here again, this p-value, I'm going to go back to our slides. This is the value we would use to either reject or fail to reject the null hypothesis. And it also has already been calculated. Lastly, I'm given p hat, which is 0.5. So this is the sample proportion. I'm also given that n is equal to 277. So remember that n would be the number of people, or in this case, the number of trials. All right. So now we'll actually read through the problem. So it says that a certain drug is used to treat asthma. In a clinical trial of the drug, 16 of 277 treated subjects experienced headaches. The accompanying calculator display, right, as we see to the right, the calculator displays show results from the test of a claim at less than 9%. So remember, my null hypothesis would be equal to 9%. And my alternative hypothesis is less than 9%. So in our calculator printout, we're given that alternative hypothesis is less than. So less than 9% of treated subjects experience headaches. Use a normal distribution as an approximation to the binomial and assume a significance level of 0.01. Right, so our significance level is 0.01. And later in the problem, we will use this significance level and we'll use this p-value and we'll make a determination about the null hypothesis. All right, so now we'll go through the problem. So is this a two-tail, left tail, or right tail test? Well, from our given alternative hypothesis, we see that it's less than, so this would be a left tail test. We're asked for the test statistic. The test statistic is negative 1.87. We are asked for the p-value. If we take a look at the given data, the p-value is 0.0304. That's 0.304. And now we're asked to determine the null hypothesis. So remember that the null hypothesis is equal to, so our claim value is 0.09. And now we're asked to make some decisions about the null hypothesis. Well, I have to take two values in mind. I have to take in the p-value, which is 0.03, and the significance level, which is 0.01. And when comparing the two numbers, notice that our p-value is larger than our significance level. Right, 0.03 is a bigger number than 0.01. So if I go back to the p-value method, our p-value is greater than our significance level, so we would fail to reject the null hypothesis. Okay, there is not sufficient enough evidence to support the claim that less than 9% of the treated subjects experience headaches. All right, so our correct answer choice here would be D. Now, if I wanted to use the calculator to get these same statistics, all right, so I'm going to go into statistics. I'm going to scroll over to tests, and I'm going to go down to a one proportion z-test. I'm going to put in my population, my claim population, which is 9%, so that's 0.09. I'm going to put in X. X is going to be 16. There were 16 subjects that were treated for asthma. I'm going to put in N, which is 277. My alternative hypothesis is less than, so I'm going to select enter to log that in. I'm going to go down to calculate. And notice our test statistics. We have the z-score, which is negative 1.87. We have P, which is 0.0304. We have our sample population proportion, which is 0.05. And we have N, which is 277. All right, so I'm going to stop the recording.